assim, o sentido dessas funções, dessas sessões, elas serem feitas em inglês, até porque, eventualmente, o Congresso tem algumas pessoas de fora que podem aparecer mais tarde, eventualmente, aí você não vai ver, eu não vou ver e tal. Eu acho que a gente deve seguir o protocolo e fazer em inglês, tá? Então, a partir desse momento, a gente muda, a gente vira a chavinha na medida do possível, tá? So, guys, let's go. Officially, it's 5 hours and 4 minutes. We have here the paper 3055, Independence or Copulas, Capturing the Independence Among Large Losses Using Extreme Value Copulas. The authors are Tiago Dutra de Araújo from the University of São Paulo, and my colleague, Professor João Vinícius de França Carvalho, also from the university. And Tiago, you have 25 or 30 minutes for the presentation. Then, as a discussant, I will make some comments and suggestions about your paper, okay? So let's go, good luck.
Thank you, Professor. Let's share my screen.
It's perfectly clear, Thiago.
Yeah. Okay. Can you see?
Yes.
Yes. Oh, okay. Thank you, Professor Luis Afonso, for your kind presentation, and thank you everybody to be here. The title of this study is Independence or Copulas, Capturing the Dependence Among Large Losses Use Extreme Value Copulas. I am Tiago Dutra, and this work was made with Professor Dr. João Carvalho. So let's start. If an insurance company wants to operate in several lines of business, it needs to be aware of the fact that some events can generate payments in more than one of these lines. In particular, if the event is an extreme event, an incorrect price can lead the insured to bankruptcy. One way to improve extreme events pricing models is via copulas, a statistical model used in the last 3 decades. However, the literature about this is limited, and articles using real-world microdata are even rare. So, the objective of this work was estimate the dependency structure among large losses from a single event that generated multiple claims in different lines of business using extreme value copulas, EVC, applying to real-world insurance data and compare it to other families of copulas. For this, we used a cross-validation copula information criterion, CIC, to select the most ranked model from a list of copulas. And once the copula model is selected, we estimated the copula parameter using 3 possibilities. Let's see some details about this. According to the literature, the higher the CIC, most suitable is the model. Using this criterion, we analyzed 9 copula models belonging to 3 families: elliptical, Archimedean, or extreme value copulas. From elliptical family, we have Gaussian and T-student copulas. From Archimedean family, we have Clayton, Frank, and Joy copulas. And from extreme value family, we have Gamble, Tal, Galambos, and Rosler-Rees copulas. One important detail: the CIC is a criterion for model selection based in the best ranked model from a list of copulas. This not means that the copula chosen is the best copula to fit the data. It's quite different to the goodness of fit test, where is evaluated if the fitting of a copula is rejected or not. According to Hofer and al., goodness of fit testing is a key step when searching for an acceptable parametric copula model for the data. However, when the sample size is small, it's not uncommon that none of the candidate parametric copula models are rejected, meaning that all candidate models are plausible. Or When the sample size is large, it can happen that all the candidate models are rejected. The CIC criterion only indicates that from this list, which is the best suitable model, okay? We choose these 9 models because all of them are uniparametric copulas, whose parameter can be estimated in the following ways. The first is the method of moments estimator. In this method, we first calculate the estimator of Kendall-Stahl using the sample version of this measure, and calculate the copula parameter by the inverse of the function that provides Stahl given a value of theta. The second way is the maximum pseudo likelihood estimator, Mple. In this method, we first create a sample of pseudo observations from the observed pair XY and calculate the estimator using the maximum log likelihood from these pseudo observations. A third way, used only for extreme value copulas, is the method of Capira-Fugger's genus. This is a non-parametric way to estimate the Peakan's dependence function for extreme value copulas. As you can see, in this study, we used the Ludendorff-Unsiger's version. To evaluate the effectiveness of this method, we simulated data whose dependency structure was already known before used it to capture the dependency structure in real-world data, containing losses belonging to different lines of business in auto insurance, incurred by a single event whose dependency is typically unknown. For this, we defined 3 scenarios. The first, called the week, has 10,000 pairs simulated from a Gaussian copula with tau equals to 0.1. The moderate scenario has 10,000 pairs simulated from a Joe copula with tau equals to 0.4. And the strong scenario has 100 pairs simulated from a Russell-Reese copula with tau equals to 0.7. These scenarios simulated weak, moderate, and strong correlation. In the 3 scenarios, we assumed that X and Y have exponential distribution because of its well-known mathematical properties. The mean value of X and Y were chosen equal to the means of individual severities of the 2 lines of business real data, given by 8,500 Brazilian real occurrence and 5,000 Brazilian real. Calculating the CIC for these scenarios, we obtain the following table. Just for remember, higher the CIC, better the model. So this table shows that the best family for these scenarios are indeed Gaussian, Joe, and Russell-Reese. As much as the method correctly indicated each copula model for all scenarios, one can see that in the weak scenario, the CIC values of the Gaussian and T-student copulas are practically the same. However, the T-student's copula for the CIC has almost 1,400 degrees of freedom, which indicates proximity to a Gaussian. In the moderate scenario, the negative CIC value of the Clayton copula indicates how far this copula is from being the best model to capture this dependence. After the copula family has been chosen, we estimated its parameter, showing the following table. Note that the estimator generated by the Mple method has a higher log likelihood and lower standard deviation than the one generated by the MNE method, showing that the Mple estimator is more adequate than the MNE. This occurs in all three scenarios. Once obtained the parameters of these three copulas, we calculate the upper tail coefficient parameter. The values obtained indicates that of these three scenarios, the extreme value copula is the one with the highest dependence on the upper tail. This is a very important measure of association to analyze the extreme events because it looks to the upper tail of the joint distribution of losses. After this, we analyzed the use of MCFG to obtain an estimator for the Peakan's dependency function for extreme value couples. For this, we defined 4 data sets, each with 150 pairs simulated from each of the extreme value couples using the exponential distributions that were used in the weak, moderate, and strong scenarios. These graphs compare this method and the Peakan's dependency function. Once again, according to the literature, the proximity between the graph and the horizontal dashed lines indicates independence among X and Y. Other way, the proximity of the graph with the sloping dashed lines indicates complete dependence among X and Y. So this graph shows there is very little difference between the MCFG estimator, indicated by the blue line, and the dependency function, indicated by the colored line. Furthermore, extreme value copulas capture a high dependence in the upper tail, this region. In addition, the tau copula is more sensitive to the difference between these two methods, probably because the value of tau. Once verified that CIC correctly captured the family of copula, and Mple and MCFG generated consistent estimators, we applied this method to real-world microdata. The data contain policies that generated multiple payments in Brazilian real currency in different Brazilian insurance lines of business from January 2007 to May 2012. To make the incomparable, all monetary values are brought to the constant currency of May 2012. The policies belong to these 6 Brazilian lines of business. This table shows some statistics about these policies: number of observation, mean of X plus Y, median, standard deviation, and maximum. From this table, we can note that in the 4 types of pair of lines, the mean of the total per policy is higher than the median. This happened in all 4 scenarios. This, together with the higher standard deviations, high maximum payment per policy, and low number of observation in 3 of the 4 pairs suggests the presence of extreme events in this company's portfolio. From these pairs, we analyzed 10 scenarios. The first 7 being relative to the pair 0531, 0553, considering 1, all data of the pair, 2, 90% quantile in each of lines, 95% quantile in each of lines, 99.5% quantile in each of lines, 90% quantile in some of lines, 95% quantile in some of lines, 99.5% quantile in some of lines. The other scenarios are all data in another pair of lines. We constructed the scenarios 5, 6, and 7 because, according to some authors like Sweden Fortune, Sun et al., An extreme event can generate multiple claims that are not as severe as in an isolated line of business. However, as the insurance company pays the total amount claimed, when adding the indemnity from another line originating from the same event, it may occur that the total amount exceeds a certain limit. So scenarios 5, 6, and 7 can generate the results quite different from scenarios 2, 3, and 4. Well, calculating the CIC, we found that extreme value copulas were the best family in 4 of these scenarios. The best copula model in each scenario are shown, as well as the copula parameter estimator using Mple. For scenarios that we use all data of the pair, we constructed the graph of joint probability density. In particular, please look the density in the upper tail of these scenarios. This graph shows that if an insurance company decides to offer policies with multiple coverages, it cannot ignore the fact that large losses occur jointly. There is high density in the high quantiles of both lines. After restricting the pair 0531, 0553 to some quantiles, extreme value copulas are better to capture independence in cases which only events that generated large losses in both lines, but don't do so in cases with an event generated a high indemnity in one line, but not on the other. When these cases are also included, the dependency structure is modified in order to capture this dependence as well. In scenarios 2 and 4, extreme value copulas were replaced by a T-student copulas, scenarios 5 and 7. Please look at the graphs. These are scenarios 2 and 4, and these are scenarios 5 and 7. Look how the dependency structure is changing. To illustrate the difference between these scenarios, the following table shows the corresponding values to 99.5% quantile in each of line and the sum of the losses. One of the policies in portfolio generated the following payments in each line, corresponding the sum. Look that this policy is not included in scenario 4 because the amount in second line is less than the quantile. However, this policy is included in scenario 7 because the sum is higher than the quantile, illustrating the difference between the dependency structures in scenarios 2 and 4 in relation to 5 and 7. This table shows the upper tail coefficient for each scenario. In the extreme value copulas, this coefficient was calculated using Peakan's dependency function, DF, and the MCFG method. Note that if the insurance company considers only the values of upper tail coefficients of scenarios in which the sum of the losses is evaluated to mention its solvency capital, and not each line of business individually, it may be exposed to the risk of insolvency if occurs an extreme event. Look at the variation between these coefficients by comparing the scenarios in which each line is considered individually and each respective scenario considering the sum of the losses. In scenario 2, the value obtained was more than 2,000% higher than that obtained in scenario 5. And in scenario 4, the value obtained was more than 3,500% higher than that obtained in scenario 7. These high variations strongly reflect the increase in the level of exposure to insolvency risk of this company due to some extreme event. Analyze the sensitivity of the MCFG method to the Peakan's dependency function. It is noted that in scenario 4, the MCFG method indicated an even higher dependence on the upper tail than that indicated by DF method. The following graph helps to see this. Note that the blue line is nearer to the slope and dashed lines than the peak, especially for T higher than 0.4. Well, as a contribution of this work, it's interesting to note that SUSEP, the Brazilian Insurance Regulatory Agency, groups different lines of business in the so-called classes of business and measure the dependence among these classes in its methodology for calculating the risk capital. Just for curiosity, they use elliptical copulas to obtain these correlation parameters, instead of measuring the dependence among the lines of business. So, SUSEP does not predict, neither quantify the dependence among every pair of Brazilian lines of business in calculating the insurance company's risk capital. However, this study showed that this dependence exists and is relevant for the calculation of solvency capital, especially for insurance companies that operated in different lines, which may be exposed to greater risks than they believe they are. Still, some of the dependency obtained among the lines of business quantified is higher than that calculated by SUSEP, indicating that the insurance company's solvency capital does not correctly predict extreme events, which is dangerous. So, the regulator should be aware of these facts when dimensioning the minimum capital requirement. So, this is it. Thank you very much for your time and attention. Or how do you say in Brazil? Obrigado.
Congratulations for the presentation, Thiago. Very, very good presentation and extremely on time. And I think I can share my screen. Oops, just a second. Can you see it's not only copulas, but it's especially the choice of the copula family. I learned a lot about many different names and different kinds of copulas, and for modeling the dependency structure. And I think especially the paper has, first, a very important contribution for the academia, not only in Brazil, and also for the market, especially for the suppliers, for the insurance companies. And there is this strong message for the insurance companies and for the regulator. I have to say that I was sort of, I wouldn't say scared, but mainly worried about the conclusions of the paper. But because it worries me about your conclusions. Not what you said, but especially what the regulator probably is not looking at. So sections 1 and 2 are very, very good, very well written. And I think you mention a lot of papers, a very synthetic approach. But in this case, you know, that's my bias in this issue, not your bias. And I'm not saying that I'm right and you're wrong, just a different point of view, okay? And I think in this case, it depends who your reader is. And I'm not a typical expert in this topic. And you mentioned a lot of papers that talk about the importance of modeling dependence among events in the pricing of claims, or not. Let me try to explain why this or not. Because I think you didn't bring any example, good or bad, about this kind of modeling. And I have two questions now. Are there any good examples of bad practices? For example, an insurance company didn't use a correct modeling of the dependence, and there was some kind of problem. And I don't know, after a World Trade Center, after Katrina, COVID, or something like this. And the second question related to the first one, is this the practice in the insurance industry? Or people, the insurance company, the actuaries, they don't know this kind of stuff? I would like to hear from you.
Do you prefer that we answer right now or?
Right now.
Okay. Thank you very much for your kind introduction about our paper and specifically about this empirical evidence in the literature. I must say that it's really, really rare that we find some piece of evidence in academia. I think this is our main contribution, that we shed light to this evidence that usually not only regulators, but also insurance companies use this microdata to fit adequate models to use it in minimum capital requirements.
I have no doubt about it.
But exactly due to of this, it's really, really rare that we find good and bad examples in the insurance industry. We must say that we presented this paper in Austin Colloquium last May, and one German expert in copula modeling asked us about this is the exactly phrase that he spoke. Is your regulator aware of the fact that you don't use copula modeling for capturing extreme value situation in your country? And I told him that this is the second paper that we use copulas using data from insurance industry, but this is the very first one that we use microdata. So it's really much complicated that we tell the government, tell the agency to look at this sum of events, sum of values to specifically monitor the fat tails events. So in Brazil, it's unexisting, but also in other countries, we couldn't, of course, at the best of our knowledge, to find this kind of evidence. And this professor was really not upset, it's not the word, but worried about this kind of situation, because regulators usually don't look at fat tails events and cannot model it properly, I mean.
Yeah, because this kind of example, that's why I asked you, it would be sort of a holy grail.
Mm-hmm.
Greatest example that you could find.
Mm-hmm.
You know, that, I don't know, AIG in the crisis, something like this.
Mm-hmm.
That's, if you could find, I'm not saying that it exists. I know it's hard, because it's a sort of an internal practice of the company.
Yeah, exactly. For insurance companies, it's pretty rare, but we try to find it through papers that has used this kind of data. We're not.
You couldn't
able
find.
to find it.
Okay.
But it's a very important question because regulators should be aware of this fact, and we provide one piece of evidence to show that that matrix that they use, that Thiago showed us a little bit earlier, should be recalculated. This is a continuation of our paper, Tanaka and Carvalho, 2019, that we use time series data, time serial data, using Archimedean copulas, but we were not able to find this kind of fat tail events. But there was an evidence showing that could be pretty inaccurate that matrix to calculate minimum solvency capital and so on.
Okay. And section 3 is a very didactic and comprehensive explanation about copulas and estimation methods. Very, very good explanation. Well, I can imagine how hard it was to make a decision. Wow, this is going to be in the paper. No, don't use this formula. Oh, no, it's too many lines. No, too many equations. I know it's very
good
good.
For your comment, Luis, because that was precisely what happened with me and Thiago. Because in my own papers, I always, as you mentioned before, I always try to bring much mathematical formulas and different methods to solve the case that we are treating. But I think, and we decided to bring all these kinds of methods and also different families of copulas, because I think it's very didactic, and we must present to our community new lines of thinking, because it's very important that regulators keep in contact with academia, and other researchers can understand in very didactic way what we are doing and what we are about to solve, what kind of problems can be attacked from this perspective. So I think it's very important to keep in paper, and especially trying to bring different approaches of estimating parameters.
I think it was absolutely right, because you show a lot of copulas, then you estimate, you explain the reasoning of your choices, you explain the criterion, and I think it was perfect. It was a very, very good strategy.
And another thing, important thing, and I always try to, and Thiago developed it in a very good way. I'm trying to make the study in two different parts. One, lab simulation, that we treat and test different methodologies, and bringing those conclusions to real world microdata. This is very important, because we must know what we are treating and how these different methods can bring solutions to our conclusions and so on.
So section 4, the results. It's divided in two parts. The first one, the simulations, and the second one, the real world. And when you start doing the simulations, you show a lot of figures and graphs, and
graphs.
It's figure 1. I think in the beginning of the section, you just start the session showing, oh, we're gonna make a lot of figures and graphs. Just a suggestion, just a formal suggestion and a minor suggestion. Write an explanatory paragraph in the beginning, like saying, oh, we're gonna do this and this. This is important for this and this is important for that. Just to show the way to the reader, especially if the reader, it's not my case, doesn't know anything about copulas.
Thank you very much.
And it's not clear, probably I forgot to read something. Why did you choose these values of tau, x and y, 0.4 and later 0.7? I think it's just say, we fix the tau equal 0.4. Why did you choose that?
Mm-hmm. It was a choice that we made to turn our simulations viable. Just because I asked Thiago to drop this reference out, but this is the reason why we maybe you didn't find this mention in the text. But it's important to know how the model fits in adequate way in different strength of dependency structure. This is why we chose 0.1, 0.5, and 0.7 to know or to feel how the model perform, or how is the performance of different methods and models or under these different values of tau. It could be lower or higher, maybe 0.7 could be 0.9, but we decided to do it following prescriptionary descriptive statistics. And I asked Thiago to
this choice. This is a discretionary choice.
Yeah, discretionary, totally.
Okay. Certainly an expert in copulas would say, well, it's okay, 0.4, it's great, everybody uses that. Mm-hmm. But if someone who's not familiar with this literature, the question is, why? Mm-hmm. Is everybody using 0.4? How sensitive are the results to change this coefficient? I don't know. Mm-hmm. Maybe a minor explanation, okay? All right. And also in this case, when you start showing this beautiful figure 1 and going to the beautiful figure 2, and I don't know, maybe you should emphasize a bit more the hypothesis and the assumptions that you are using in this case, because there's a lot of information here, a lot. So, and certainly there are some assumptions. I think you described the assumptions and the models, but maybe more, I don't know exactly, how could you do not making the paper become a 45 pages, mm-hmm. But I don't know exactly how you could do it. Mm-hmm. I would like to hear from you, this beautiful figure 2, when you show the joint probability densities with Gaussian, Joe, and Hursley-Rees copulas. What's the interpretation of these figures? Could you say a little bit more?
The joint probability densities ones, right? This is a three-dimensional graph showing how the dots and the simulated data are distributed over them, between them. I mean, this is a joint probability density function, meaning that there is high concentration in some of the tails, and you can see it that go upper, or upper level in specifically entails justifying the use of these kind of models, that we must pay very high attention to that specific part of the joint distribution function. I mean, how the data is jointly distributed, how likely they occur, and what could be the main adequate model to fit that specific region of the data, the joint data.
Mm-hmm.
The upper levels, I mean, the higher density means that that specific part occurs more than we expected from the middle or near the mean of the distribution, the probability distribution. It's not a normal distribution. This is the reason why the Pearson coefficient is not adequate to model the joint occurrence of the data. This is the reason why we use also the tau instead of the whole Pearson's row coefficient of correlation.
So here we go for the real world microdata. We have 6 business lines from an insurance company. And I don't know, maybe just my impression, maybe you should stress or emphasize the connection between tables 10, 11, 12, and figures 4 and 5. I don't know, it's just my impression, not sure if I'm right. Okay, and
I think you're right, because it's important to mention that we are trying to model specific lines of business, and we must connect them to the outputs of the modeling. I agree with you completely.
Mm-hmm. So we have here some data from table 10 with the number of observations. And we can see that the first pair represents 99.58%, and the other ones are quite small, 0.18, 0.12. Okay. What caused my attention to the first pair, that these lines are automobile whole and automobile optional civil liability for vehicles. Okay, and but at the same time, the third line, this one,
mm-hmm.
In this case, the maximum is the highest value, even higher for the first one.
Mm-hmm.
So it must be important. This is important. This is important. I'm not entirely convinced that it's so important to analyze this correlation and this pair. And also a question that did not occur at the first time. And we're talking about pairs of lines, but I was thinking of, if I purchase an insurance policy from automobile, probably I will buy 531, 553, and I don't know which one, 520.
20.
How did you manage to deal with the data when there are more than 3 lines in the same insurance in the same claim?
That's a very good question, and this is the heart of our work, because when we deal with comprehensive policies, not comprehensive in the sense that you wrote in the slide, comprehensive composed policies that you were talking about. Composed policies is one policy that cover three or many different lines of business. Once you purchase one of these composed policy, once you get a generate event like a crash in your automobile, you generally, you activate more than one of these lines of business. This is the reason that we try to separate different lines from for our modeling purpose. I mean, when you crash your car, you can damage the hull itself, another third party, and also your passenger. And when you do so, you activate by one only generate event 3 different coverages. This is exactly what we are trying to model. And when we compare the first line that you mentioned that it's important, it is really important because it is the vast majority of our database. Who and third-party liabilities is when you crash your car in another car, and and then you activate 2 coverages. So SUSEP obligates every insurance company, even in composed policies, to differentiate or allocate proportionally the premiums for technical provision's sake to manage specifically each line of business. This is mandatory for regulation purpose. But we are trying to not look at this obligation and come back to one only generator event that provide us evidence that this could happen, this event could happen and generate multiple events, multiple indemnities. So this is really important to mention. Sorry, the first and the last line of this table are related to automobile policies. But in exactly due to what I was previously said, that insurance policies, automobile insurance policies in Brazil usually deals with these 3 coverages, different coverages. But the 2 of the second and the third line deals with usually business kind of policy, insurance policies, like
it's a multi-risk.
Multi-risk, yeah, exactly. Third-party liabilities in general, multiple risks 78, and specifically 0118 and 0351 deals with business enterprises, like business buildings. You know that people that drive your car when you arrive at one place, and this guy maybe drive your car and crash into the wall, the main responsibility is due to the company that claims for indemnity to the driver, to the car owner, and then activates this kind of coverage. But specifically about 18, usually is this kind of situation, but there is, you mentioned, that is one big severity related to this specific line of business. That was one situation that the building collapsed and of course damaged every car that was inside the building, in the garage. So this is the reason why we decided to deal with these different lines of business, because we were able to find one event that generate multiple claims in different lines of business, and most part, of course, was related to composed insurance policy. This is why we saw too many policies related to the first line.
This question actually is the same question that we were talking in the beginning, rephrased. Sort of a Chicago economist joke. if there's any evidence that insurance companies don't take dependency into account. Mm-hmm. Because it's very important for their business. Their life depends on dependence.
Yeah, their business depends on
they
that.
They should take this into account. Our former students, they are working in these companies.
Yeah, exactly. You're absolutely right. But it's important to mention that our regulator obligates everyone, every single company to follow their methodology to calculate business. And there is one specific article in the one of pronunciations or law or I don't remember the legal instrument that contains it, but they are very clear about managing lines of business. Each line of business must be solvent per se. This is the reason why they manage independently from each other lines of business.
That was sort of my questions. Looking to look into the future or in the end. As I mentioned before, I'm sort of worried about your conclusions, not your conclusions per se, but the outlook in the insurance market in Brazil. And because we are extremely regulated in Brazil, but we're going through many changes in the regulatory framework. Regulatory sandbox, open insurance, pay-as-you-go insurance, insurtech, and lots of things. And I'm not sure if I can read the paper this way, but the question is the regulator aware of these issues that you are finding in the paper? And are the companies aware of the issues and the conclusions that you're bringing in the paper?
I feel like a deja vu happening, because this was the very question that that professor made us in last May during Austin Colloquium. I think they are not aware of this fact, because if they were, they should give another matrix of dependence to measure this kind of risks, or they should allow companies to make sensitivity analysis to stress some results like minimum solvency capital or even technical provisions. I don't know if I'm right or wrong, of course, but this is what I try to say to every student, including Thiago. We have a huge, not only big, huge responsibility to bring some kind of evidence to give this kind of alerts. Regulators, insurance companies, take a look at fat tails event and understand how they impact your own business, because as you mentioned, as the Chicago Economist joke stated, they should be aware, even inside companies, not only regulators, to pay attention to these kind of fat tails, dependent structures, and why don't do so? I think they are not trained mentally and technologically to deal with kind of these events. I myself asked personally to Mple yesterday if undergrad students take contact with this kind of methodology, copula model, copula modeling, Bayesian inference statistics, and usually, very often, our practitioners don't understand this kind of methodology to include on their own work. So this is
exactly the point, because you're talking about automobile, there are a lot of policies.
30% of the Brazilian insurance market.
And what happens with insurance companies that sell large risks policies?
They are covered by reinsurance, which is very comfortable for them to deal with these kind of problems, because once it happens, they only transfer to reinsurance companies. So that reinsurance companies must be much aware than insurance properly. So exactly
what you're saying, if we don't take account correctly of the risks and you don't price correctly, in some case, who pays the price is the reinsurer.
Yeah, exactly.
And the reinsurer, it doesn't know that.
I hope that they are aware of this fact, but myself, I don't know if they are dealing with. I have some private information, of course, from my former students that deal with on a daily basis with reinsurance, that they export the modeling to Europe. They calculate everything that is needed to price policies or calculate reserves. But in Brazil, we don't have this kind of technology and team to price our own risks.
But their life depends on that.
Yeah.
We're not talking about anything that's unimportant, that's too small. It's their business. They should know that.
Yeah, but we brought some evidence that we are in the previous paper, I mean, Tanaka and Carvalho, 2019, that for regular basis, we have much more capital than we needed in Brazil. In Brazil, we are more than solvent on every line of business and for every insurance company acting in different sectors, since annuities or large risks and automobiles. But we have some evidence that shows in that paper that for extreme event scenarios, we may be uncovered to deal with those kind of situations.
Okay, guys, great discussion, great paper, but I got this message in the chat. Professor, infelizmente precisamos fechar a sala, é verdade, porque a gente já estourou o tempo. Então, parabéns, João, parabéns, Thiago, muito, muito legal, tá? Infelizmente, a seleta audiência não teve tempo, eventualmente, de fazer questões, tá? Mas fique à vontade, todas as pessoas